Okay, testing, testing. Here we go. All right, so this is a example problem out of section 1.3, number 18. So the first thing we'll look at, don't have my tablet going here. Oh, there we go. Now we're working. Is we've got this function f of x equals 3x cubed. Step A says find the inverse functioners. So step A, what we're going to do is find the inverse function. We'll start that out by solving for x. So step one, again, whenever we do this, is to solve for x. So to solve for x, so we take f of x. So really what we have right now is, oops, there we go, is y equals 3x cubed. All right, so the first thing I'm going to do is I'm going to divide by 3. So I'm going to get y divided by 3 equals x cubed. And then I'll take that a step further, which would be to take the cube root of both sides. So I'll go over here and I'll get that, if I take the cube root of this side and the cube root of this side, the cube root of this side over here gets rid of the x cubed. I'm going to write that here. I'm going to write x equals, because cube root of x cubed is x, equals the cube root of y over 3. And then the step 2, when you're looking for an inverse again, was just to switch the x and the y. So y equals the cube root of x over 3. I just switched the x and the y. And then we typically rewrite that as f of minus 1 of x, the inverse function, is equal to the cube root of x over 3. Just like so. So that would be that'd be the A part of this problem. So A is that part up there. There is our inverse function right there. Well, our original function and our inverse function. Now in the next step, on step B, it actually asks us to do something a little different. It says show that the f of minus 1 of x equals x. So what we're going to do there is we're going to say, well, let's figure out how this works. Well, it would be f, I'm going to rewrite that thing just so I can kind of get a handle on it, of the f of minus 1 of x. And we want to show that that's equal to x. So I'm going to just manipulate this guy and try to prove to everyone that that's actually equal to x. So what I'm going to do is I'm going to substitute in the inverse function. So I know that f minus 1 of x equals the cube root of x over 3. So I can say this is actually equal to the f of, substitute in here, f of minus 1 of x, which is actually this. So it's actually the f of the cube root of x over 3. All right, so I can see how that works and say, okay, that's not too bad. I can deal with that. But now I've got to do the f of this. And remember what that really means. The f of this means I go back to my original function, which is the f of x. And everywhere there's x, I'm going to write whatever's inside here. So if I said f of 2, 2 would go in for x. I'd cube 2, and then I'd multiply it by 3. But in this case, this is actually going to be 3 times whatever is in here. So it's going to be 3 times the cube root of x over 3. And then we can see that's to the third power. So that's going to go to the third power. The nice thing about that is it does a couple of things. If I cube a cube root, that's essentially like squaring a square root. It basically undoes itself. So what I really get is the raised to the exponent of 3 and the cube root actually undo each other. So I end up with 3 times x over 3, which is equal to 3x over 3, which is equal to x. And that's what we were supposed to prove. Basically, it's kind of like a mathematical proof. We want to prove that this is going to take us back to x, which it did. And a lot of times when we do a proof like this, we'll draw this little square and shade it in, or sometimes they'll mathematicians will write QED, Can't remember what that stands for, but it's some sort of Latin term, which is that which is to be proven or which is shown or something like that. Either one of these, both of these are saying is you're done. We want to show, and anytime we use the word show, that's really saying that this is a proof. We want to show it, and we end a proof. I actually prefer to end a proof with this little rectangle. So that's a proof. And that's it for number 18.